in section 5.2, we are talking about polynomials still, but today we're going to talk about their linear factors and their zeros. Zeros just means they're solutions, right? Okay. So I'm going to start right off the bat here. We're going to be doing a lot of factoring today. Okay? Not a lot of factoring, but factoring. The whole idea behind factoring is that you can find your zeros or your answers by setting each factor equal to 0. Okay? So we are doing the zero product property. And in that zero product property, it says to set any factor with a variable equal to 0 and solve. So if we have a factor, let's say we have 2x times x plus 1 times x minus 3. We're going to set anyone with a variable in it equal to x, or equal to 0. So I have 2x equals 0, I have x plus 1 equals 0, and I have x minus 3 equals 0. Solving the first one, I get x equals 0, then I get x equals negative 1, and we get x equals 3. If you look at our factored form, there's 3 x's, which means we have to have 3 solutions. Okay? And tell me, what do the solutions mean? Yes, it's where they cross the x-axis. So imagine this has 3 x's, so it's x to the third power. It's going to cross the x-axis 3 times. It's going to look something like this. It makes sense that it crosses in 3 places, right? Alright, so just to kind of put last chapter, attaching it to this chapter, that's what we did. So, I want to start by example number 1. Clarifying 8 through 12. All you have to do is factor completely. Correct, not solve. That's why I want to clarify. There is no equal sign anywhere. You are just factoring. Okay? So, let's start off with something as wonderful as x to the third minus 4x squared minus 21x. Good. We can take an x out. What does that leave us with, Brady? Good. Then what do you want to do to continue factoring this? Good. So negative 21 on top, negative 4 on the bottom. What are the sides? Good. Negative 7 and 3. Do I have to do the box in this case? No? Okay. So we have x minus 7. We have x plus 3. Perfect. Exactly. So you'll notice you have 3 factors with x in them, and look at your highest exponent. It is a 3. Okay? Goes together. Right? That's the first section. I don't think we have to go over factoring anymore. We've done a lot. Okay. So then, moving on to the next section, example number 2. This is going to say find the zeros of the function. And they're so kind. Oh, well, and then graph. Then graph. Now, when I say graph, I want you to think of it as a sketch. And I'm going to explain why in a second. Okay. So, let's say I have, it's already in factored form, all of these. So let's say I have y equals x plus 2, x minus 3, and x minus 5. Okay? First thing we have to do is find the zeros. Set them all equal to 0, right? X plus 2 equals 0. X minus 3 equals 0. And x minus 5 equals 0. And the first one, x equals negative 2. Next one, x equals 3. And then the next one, x equals 5. All right, so here's what I want you to do when you sketch. Just sketch, so it's not exact. When you sketch the graph, first of all, this tells us where it's crossing the x-axis, right? So we're going to put dots on the x-axis at negative 2, positive 3, and positive 5. Okay, exactly. Now, if you look at this, our leading coefficient here, is it positive or negative? Positive. How many x's do I have? So it's odd. Positive odd is down up. So you go to the ends and go down, up. So now, again, if you have 3, how many times does this have to turn? So we're going to turn 1 and 2 to connect it through. I don't know how high that max is. I don't know how low that min is, but I don't care. The idea is that you understand that it crosses, what the end behavior is doing, right? And how many times it's turning. Because in the front here is positive, right? If I had a negative there, this would be switched. Okay? Alright, you guys, let's do one more of these. So example number 3, still from the same section. Alright, so let's say I have y equals, let's go with negative x times x plus 1 times x minus 3, and I'm going to squeeze in an x minus 4 over there. Alright, so my first x equals what for the first factor? What? 0 for the first one, this one. This one is x equals negative 1, I agree. Here, x equals 3, and we get x equals 4. Okay, so this is going to cross the x-axis 4 times, right? All right, so let's put our dots on our graph first. We have 1 at 0. We have 1 at negative 1, 1 at 3, and 1 at 4. So, this has 4 x's. It is even. And it is what in front, Brady? Negative. So what is my end behavior? No. They're even, so it's down, down. And there are 4 of them, so how many times should this turn? 3. So we're going to turn 1, 2, 3. Kind of looks like an M. And again, I don't know those maxes and mins. We're not even going there yet. That's why I call it a sketch. All right? Not bad so far? Okay. So the next section is the one that nobody likes. It's not bad. It's just a lot of algebra. It's going to be fine. Okay? So in the next section, example number 4. This is 20 through 26. And again, that's why I stopped after this for today. Okay? Write the polynomial in standard form. Given y equals x plus 1 times x minus 2 times x plus 3. We're going to have to use the box twice, okay? There's a couple of them where you got to do it 3 times. You'll be fine. All right, so we're going to multiply these 2 together first. So I have x plus 1 times x minus 2. X times x is x squared. X times 1 is 1x. X times negative 2 is negative 2x. 1 times negative 2 is negative 2. Adding my diagonals together, I get x squared minus x minus 2 for my first 2 together. Does everybody agree? Yes? Okay. Now, when you go to multiply your result by the next one, I like to put my trinomial across the top, okay? So I'm going to put my x squared minus x minus 2 across the top. Down the side is my x plus 3. X times x squared is x to the third. X times negative x is negative x squared. X times negative 2 is negative 2x. X squared times 3 is 3x squared. Negative x times 3 is negative 3x. And negative 2 times 3 is 6. And you'll notice your diagonals add together. Yes, negative 6, thank you. Your diagonals add together. So our final result is here. We have x to the third. 3x squared and negative x squared is 2x squared. Negative 3x and negative 2x is negative and minus 6. That's it. As I said, it's a lot of, just a second. It's a lot of algebra. You know what I mean? A lot of multiplying and just writing. Right. There's a couple that the numbers get a little bit bigger, but it's not bad. Okay. So here's the next thing I want to talk about. What if it's not in that form? What if I just give you the zeros? So I give you your answers. Okay? So, sample number 5, let's say that I want you to find the polynomial. Given x equals 0, 1, 2, and 3. Yeah, so you're going to make them into factors, right? Correct. So, we're going to put an x in front. Let's go y equals. Put an x in front. This one becomes x minus 1, right? This one becomes what? X minus 2. And this one becomes? Good. Now here's what I'm going to recommend when you do it. Wait and do the x last. If you have anything ever sitting in front, do it last. Alright? So you can just distribute it through the whole thing when you're all done. Okay? So, let's go ahead and do this. Which two factors do you want to multiply together first? Alright, sounds good to me. So why don't you guys go ahead and start it. Alright, you guys try and do the first box. Let's see what we all get. Then go ahead and take your trinomial. Do you agree with my trinomial? Okay, now go ahead and multiply it by the other binomial. Oops, helps if I draw straight. Yes, exactly. Check my math. Did I get the same thing you guys did? Alright, now we still have to multiply it by x. So our final answer should be x to the fourth minus 6x to the third plus 11x squared minus 6x. Okay? Yeah, see, I like doing this stuff too. It's just algebra. But. Alright, No questions? As I said, I decided to stop there. I usually continue this lesson. And I thought, let's just stop after these boxes and see how we do. Okay? So we'll continue this same section tomorrow.